Hi everyone, welcome back to SAT 2 Math 2C. We're going to continue sort of exploration of the basic topics. Again, some of these things might look very simple or straightforward, but they're really the foundation. If you fully understand them, it's important that you understand them and know just them to be able to apply them for more complicated problems. So if you recall last time we went through a very simple sort of like description of exponents, right? So today we're going to continue on that path and talk about really two extreme cases or specific cases exponents. What I mean by that, first I'm going to talk about rational expressions, right? So what are rational expressions? Rational expressions, simply a very important definition, something that's rational means it can be converted into a fraction, okay? That's all we mean by whether anything is rational. Okay, a rational number is a number that can be converted into a fraction. So for instance, 0.333 infinite is actually a rational number. Why? Because this guy is actually equal to what? 1/3, right? Now, pi is not a rational number because it's a never-ending, non-repeating number, right? So if it's a never-ending, non-repeating decimal, then we know that's not a rational number. So anything that's repeating itself eventually could be converted into a rational number. So what's the general expression of a rational number? Well, the best way I would describe a rational number is a to the negative m power, right? That will be a pretty good description of a rational number. Why? Because what is that equal to? That's simply equal to 1 over n. So that's how we get that. Right? So if we can write all the rational numbers in the sense of an exponent, all the rules of exponents apply. Right? So for instance, if I have a to the negative m times a to the negative n, right? Well, what I get? Well, if I'm multiplying the numbers of rational expression, I will get a times negative m plus n, right? Vice versa. So in other words, 1 over a to the m times 1 over a to the n is going to be 1 over a to the m plus n, right? Again, simple demonstration. What about if we do division? Right, again, if we're dividing, so in other words, this will be what? Subtracting, right? So it's a of negative m plus n, right? Negative m, a plus n. So all these things are applicable. Again, that's why I like to put everything in perspective with exponents, because it makes the problem really easy, right? Very consistent way of doing these problems. I doubt you guys have a problem with rational expressions, except when it involves, I've highlighted here, except the case of complex fractions. Right, let's take a look at a sort of a non-complex fraction. What would I do operation-wise if I have 3 plus x divided by x squared plus 2 divided by y? Right, I'm adding, right, rational expression simply means a fraction. How do I do that? Well, to do addition and subtraction, all we need to do is what? If we want to add or subtract, the only rule we have to go by is they have to have the same base. Okay? If you want to add or subtract, you have to make sure they have the same base. So here we go. How do I make sure they have the same base? I have x squared here, I have y there, right? So what I do, multiply this guy by y, and multiply this guy by x squared. So I have the same base. What I end up getting is x squared times y, and here I'll get 3y plus xy, plus here I'll just get 2x squared. Right? You can add or subtract. If I put a subtraction sign, it's the same idea. Only do it when you have the same base. Do not touch it when you don't. Right? Very straightforward for addition and subtraction. Multiplication if you want to multiply or divide, it's even more straightforward. Okay? Let's use the same case. I have 3 plus x divided by x squared times y 2 over y. All you have to do, multiply the top and multiply the bottom. You're done, right? So I get 2 times 3 plus x divided by x squared times y, right? Very simple, very straightforward. Again, you know this already in pre-cal. You know this already from algebra, right? No need to kind of get deep into that. What if I'm dividing? If you're dividing, just make sure you're doing what? You're doing the reciprocal, right? If I change this to division, all I had to do is what? 3 plus x divided by x squared multiplied by y over 2. Just make sure you flip and make sure you do the reciprocal, right? Straightforward. It does get a little bit dicey when you get to the case of complex fractions. What's a complex fraction? To put it simple in a very simple language, complex fraction just means fraction within fraction. For instance, I have 1 over x plus 1 over y divided by 3 over x squared minus y over x y. Very messy, right? What you sometimes require to do is simplify this, right? This is what we call complex fraction. We have fraction in front of fraction. What do? Again, the rule doesn't change, right? We know we can get away by multiplying this and that by something that's exactly the same, because then we just multiply by 1. Now, what would I want to do in this case? What would I want to achieve in this case? I want to get rid of the complex roots, right? I want to get rid of complex fraction. I want to get rid of all denominators with a denominator. So all I would do is look at all these terms and say, well, what is the least common denominator? I got x, y, all right. All right, I got x and y accounted for, x squared, right? Slap a square on it, x, y, it's already there. Bingo, I am done. That's it. That's all you have to do. Right? Why do I do that? Because once you do that, it is the common denominator that will get you to actually eliminate all the denominators. So if I distribute this, I will get x squared y times 1 over x. Well, this guy cancels out with one of these, so I get xy plus, this will get me y and y cancels out. I'll get x squared, right? Here, in the numerator, in the denominator, I will get x squared, y and x squared cancels out the x squared, so it'll simply be 3y minus xy cancels out xy, so that will just be xy. Right? If you really want to be careful, although I don't recommend doing that on the test, right? Because this is not a math class, you don't need to simplify to the last step. What you could do, you can factor out a common factor, you get x, y plus 1. Here you can factor out the y, and you'll get 3 minus x. You know, to put it in very simple form. Sometimes the answer will be answer form, so make sure you do one extra step. If it's not, don't even worry about it, okay? Leave it as it is. Save time. This is what you get. If this is what the question has, leave it like that. Now, here's an alternative on the test. This is what you don't learn in class. What if they say, let's say it's not something that's straightforward, right? But use this as an example. You have a question like this, and they're saying, which of the following expression is the simplified version of this? What's the really, really easy thing to do? I will plug in. I would say x is equal to 3, y is equal to 6, right? And I'll plug in all these to get a number out of it, and I'll plug in the same numbers into the answer choices, and I'm guaranteed to get the right answer, okay? When we do a series of practice problems, I'll show you guys how to do this. But again, that's a backup plan, right? If you don't see how you can simplify this, don't worry about it. Try to plug in numbers. Say x is equal to 3, y is equal to 6, pop it in, and get the numbers out. All right, very straightforward. Now, sometimes you get something that's a little bit dicier than that. Okay, so we have x plus 2 divided by, let's say, x squared plus 5x plus 6 minus 3 x squared minus x minus 6 divided by y. Let's keep it simple. 2 x squared plus x minus 6 plus x minus 1, x plus 1, x squared minus 5 plus 6. Okay? You get something like that. In this case, it's not really that straightforward, right? Because you can't just say, all right, I'm going to multiply by this times that times that times that. That's going to be a disaster. What do we do? What do we always do? The first thing I tell you guys to do when you see something complicated, factor it, right? I don't want to see this, right? This is complicated. What am I going to do? I'm going to factor this. So it becomes x plus 2. I'm going to get what? If I factor this, I'm going to get x plus 2, x plus 3. Bingo. Minus 3, x minus 3, x plus 2, right? There we go. One more. Here, 2 divided by x plus 3, x minus 2, and here plus x plus 1 divided by x minus 2, x minus 3. Okay? Ah, beautiful. Well, this technically cancels out, so you don't even have to worry about this. Right now, how many factors are there? Well, there's 1, 2, 3, 4. Okay? So the common denominator will be that, and that. Right? So if you make the top of these 4 expressions and the bottom of the same thing, you will be able to simplify this. Again, this is a really extreme case. I want to show you guys how bad this could get, right? But even in this case, it's not bad. What's the key? You see something complicated, factor it, and get rid of it, okay? And you will be fine. So complex fraction or complex rational expressions are not that difficult, right? You just have to be careful. You have to factor. The key is find that common denominator that you can use, okay? So there's that. Now, let's move on to something that's slightly different. Let's move on to radical expressions. Okay? Radical expression. How do I express a radical? Right? It will just be what? A to the m over n. Right? A to the m over n. So again, I like to express everything in terms of exponents. Simple, right? I have, this really is equal to the nth root of a to the mth power, or this is equal to the nth root of a whole thing to the mth power. Right? Yeah. We talked about this in the last topic. I'll save some time and just show you guys this is what it is. All right. Now, what do we do with this? What are some of the things that we can do? You'll see radical expressions, right? Again, all the rules and pretty much everything that we usually deal with apply. Now, if I have, let's say, radical 3 plus radical 2, can I do this? Let's talk about operations, right? Can I really do this? The answer is no. Why not? Because you don't have the same base, right? You don't have the same base because if I want to write this, it will be 3 to the 1/2 plus 2 to the 1/2. There's no way you can add this, right? You don't have the same base. So again, with operations, if you want to add or subtract, you must have what? The same base. Again, you see the theme again, right? You gotta have the same base. So if I have 5 radical 3 plus 2 radical 3, then in this case you have the same base you get. Treat them as your x and y's, right? You're gonna get what? 7 radical 3. And that's it, okay? Subtraction will be the same thing, right? Multiplication is a lot easier. If you want to multiply or divide, radical 3 times radical 2 will simply be equal to radical 6, right? You just multiply what's in there. Same thing if you want to do radical 3 divided by radical 2, it would just be radical 3 over 2. Right? Here's another question. Can I do radical 3 divided by third root of radical 2? The answer is no. You can't do that. Okay? You got to have the same radical to be able to do it. So, operation-wise, again, very much like rational expressions, right? If you're looking at radical expressions, the key is that you have to have the same base. Okay? That's the key. So, let's take a look at some of the kind of questions that they might require you to answer. Usually, when you see a radical number, right, you get what we call a complex number. Or just a combined number. Let's stick with the simpler one. What if you have, right? That's a typical complex number. That's what you'll see. Radical a plus b. You can't combine the two because, you know, this is rational, this is not rational. Right? You can't combine the two. So, but if I want to add, if I have, let's say, radical 3 plus 4 plus 5 radical 3 plus 10, can I work this out? Yes, you can do the radical ones, and then you can add what? The rational ones. Right? So I will get, again, keep in mind, they have to be the same base. I get 6 radical 3 plus 14. Right? So it's not entirely that complicated. Now, what if this guy is this guy is your denominator? Right? What if this guy's your denominator? What could you do? In this case, you say, well, here we go. I need to what they call rationalize denominator, because mathematicians don't like to have radicals in a denominator. Okay? They don't like to have radicals in the denominator. Now, what is one thing we can take advantage of? Keep in mind this rule. Remember the difference of squares? If I have a plus b times a minus b, right? I can get a squared minus b squared. Simply means if I have two numbers adding and subtracting, and if I multiply them, I'll get the square. Why do I want to take the square into account in this case? Because if I do the square, I can get rid of, what is the square of a radical? I get rid of the radical, right? So really the key here is to do what? The key here is to multiply what we call conjugate. What's a conjugate? This is the conjugate of that. A plus b is the conjugate of a minus b, vice versa. A minus b is conjugate of a plus b. Okay? So what's the conjugate of the radical x minus 10? It will be radical x plus 10. Well, again, keep in mind, you got to multiply top and bottom. Right? You got to multiply top and bottom. Now what do we get? Because we got to go by this rule, right? It's a plus b times a minus b. It will be a squared minus b squared. So the denominator really becomes square root of x squared, right, minus 10 squared. And the top will become 3 plus x times radical x plus 10. Right, now what's x square root of x squared? That's simply x minus 100. Bingo. I just rationalize my denominator, right? This becomes a rational number, right? No longer a radical. And the top gets a little bit messy. Of course, the top is not going to be completely rationalized. Top will be 3 radical x plus 30 plus x radical x plus 10x. Yeah, the top is a little bit messy, but again, mathematicians prefer this form because the denominator is rationalized. So again, very simple concept. The only thing you have to do is multiply by its conjugate and go by one of the rules that we know since 3rd grade, right? A squared minus b squared. So that's not bad, right? So that we kind of deal with rationalized denominator. One more thing kind of left over in this topic is, what if I have radical -1? Is this any different? No, it's radical, except this number doesn't really exist, right? No two numbers that are real we can multiply to get you a negative number, right? So what would this be? This will automatically be called imaginary. I'm pretty sure you're very familiar with I, right? Simply imaginary number. We take it out just to make our life easier. So, for instance, how do I radical -4? I will write this as 4 times -1, right? Which will be radical 4 times negative radical 1, and this will be 2i. So that's how this works, right? Again, if you write this in this format, all the other numbers can be written as sort of a complex number, right? You have simply ai plus b is a format of complex number. Again, all complex numbers go by the rules of what we learned about simplified radicals, right? Let's take a look at an example. If I have 3i plus 4 divided by 2i plus 1, right? Again, I need to rationalize this because this is technically a radical. I can't have that. So I would do what? I will multiply by its conjugate. What's the conjugate of 2i plus 1? It's 2i minus 1, right? Once I do that, this becomes relatively straightforward. Here I get 2i squared minus 1 squared. I mean, you'll do this automatically just for demonstration. Do it step by step. On top, gets slightly more complicated. You get 6i squared minus 3i plus 8i minus 4. Right? 2i squared. I squared is -1. So simply -2 minus 1. Right? And the top will be 6i squared -1, so -6 plus 5i minus 4. So all things considered, -3, 5i minus 10. You can distribute this if you want. Is 5 divided -5 over 3i minus 10 over 3 if you want. But not really a big deal. That's how you simplify. Again, everything goes down to one thing. What is that one thing you got to learn how to do? One thing you got to do when it comes to radicals is that you got to learn how to rationalize the denominator. And it's a very simple concept. Take the conjugate, whatever it is, multiply top and bottom by the conjugate, and you're done.